So in question 1, we're looking at time series data. Now time series data is data that's been recorded over a period of time. It is bivariate data. We'll look more at time series data when we start Unit 4. But we're interested here in working out what the equation of that trend line would be. Now, with a trend line, we have two features of that trend line. We have a y-intercept and a gradient. Here, the vertical intercept would be 17, making sure we read off the scale correctly. So, out of our options here, that automatically discounts A, B, and D. We also notice that the gradient of that trend line is going to be negative, so that would mean the answer would have to be E. In question 2, we've got 5 sequences here, and we want to know which of these does not define a geometric sequence. The answer to this one would be A. Now, A would actually be a arithmetic sequence. The other 4 are all geometric sequences. E obviously is 1 because we're multiplying by 4. D is 1 because we're multiplying by -1. C can be rewritten as an plus 1 is equal to 2 times an, so that again would be geometric. And B is actually geometric. It's also arithmetic because what that sequence is it's just going to be all 4s, and that would then have a common ratio of 1. So A is the only one that's not geometric. So in question 3, we have the first 5 terms of this sequence are given. The recurrence relation that generates this sequence could be, well, we could actually do this question a couple of ways. We could actually generate the first few terms of each sequence, or we can actually try to work out the rule from this sequence. There's a couple of these which are obviously not going to work out right from the beginning. A is going to be arithmetic because we're continually adding 4, so that's not going to be a possible answer. And C is geometric and we're multiplying by 3. That will work from 2 times 3 is 6, but 6 times 3 is going to be 18, so that wouldn't work either. Now, again, you can either try to work out which one of these works. So we could try B, so 2 times 2 plus 2 is 6, but 2 times 6 plus 2 is going to be 14, so B is out. We can try D. 4 times 2 is 8, subtract 2 would give us 6. 4 times 6 is 24, take 2 would give us 22. So this looks promising. 4 times 22 is 88, take 2 will give us 86, so it appears that D is going to be the correct answer, which it is. In question 4, so which of these, we've got a recursive rule here, and we're asked which of these could be used to model the scenario. Well, it's a geometric sequence. We've got a common ratio of 0.8. So that means that we're repeatedly multiplying by 0.8. You could look at this in a couple of ways. That means that it's either being multiplied by 0.8 or it's decreasing by 20% each time. So that means that A and B would be out because they would both be situations involving an arithmetic sequence. C is also out because if it grows by 80%, then we'll be multiplying by 1.8, not multiplying by 0.8. And D is the only one that works out because it has a starting value, initial value of $3,000, and the value for each of the following years is 20% less, so it's a 20% decrease. So the answer there would be D. Last question is question 5. So we've got a graph here of the value of a decreasing asset, and we're asked to work out which of these recursive rules would suit the actual model. Well, at the moment they all have an initial value of 250,000, so we can't actually discount any of them straight away. But we notice that we notice from the actual graph that it's decreasing, but it seems to be decreasing. The amount of decrease is slowly decreasing, so it's going to be on an exponential curve, so that would suggest that it's not linear. So that would mean that B and C are out. Now if we look at part A, that's going to be 1.14 to the power of n. That would be exponential growth, so that would be increasing, and the price here, the value of this asset, is decreasing. If we look at part D and part E, well, they would both represent decreases. However, part D, that would say that it's losing 86% of its value each time, whereas in part E it's only losing 14% of its value each time. This graph wouldn't be a situation where we're losing 86% of its value, because the value of the asset after 1 year would be down here approximately. So it has to be E.